Okay, then without further ado, I'll turn it over to Cameron, who's going to talk about talking tech to non-techies, as the slide says.
Thanks.
Thank you, Cameron.
So I recognize most of you. For some of you who I don't have maybe a real strong connection with yet, I hope we'll get one soon. My name is Cameron Goble. I'm a technical training specialist. I work out of HR through EOD, so Employee and Organizational Development. As a technical training specialist, my job is to help people learn how to use the tools that you all create and deploy into their environments. I'm also an IT help desk survivor. So I've worked the help desk probably for a total of about 11 years. I got my start working at America Online when America Online existed. I went from there to the Health Sciences Center where I did support for the HSC Library and Informatics Center. I've worked in the private sector as well. America Online, I did some work for a local company called Heritage Home Healthcare. And one of the things that I had to learn was how to talk technically with people who were not technically inclined with computers and web pages and stuff like that. So that's what I'm going to talk about today, is how I kind of came to understand how non-technical people and technical people can work together and communicate effectively to achieve the goals of whatever it is you're trying to do. So the first thing I want to do is tell you a story. How many of you have worked help desks? Okay, a couple. You know there's always that one person, right? There's the one who calls like reliably like clockwork every week. And they tend to have the same problem. You tend to tell them the same thing sort of over and over, and there's kind of a tension there. And there's almost a battle, like you start getting this kind of Pavlovian reflex where when the phone rings, you check the phone number if you've got caller ID, and then you kind of wait maybe for someone else to pick it up, or you just bite the bullet and you pick up the phone knowing that you're in for a struggle. There's professionalism involved with that, of course, because we're here to provide support. And the people who are calling are genuinely, they're trying to do important work. For this group, it was for Heritage Home Healthcare and Hospice. And these are nurses who go out into the community, they take their computers, and they provide medical care for people at home, either because they're sick or because they're in hospice. So this is important work. The computers that we were calling these people upon to use used a cellular wireless connection to synchronize up to a database where they would put in their notes and things like that. Important work, but there was one person who you could pretty much tell you were going to get a call every week. Thankfully, I don't remember her name. I think I might have blocked it out. But she would call every week, and we would have a struggle to get her connected. And it was always the same problem, and it was always the same steps, and it was always the same. I've got to summon something inside to not be frustrated here, right? That's just part of doing the job of a help desk. The company's Christmas gathering came along one year, and it was being held here in Albuquerque, so it was easy for me to show up. But Heritage is across 2 states and like 5 cities, so people were flying in from all over. And so we go, and they've got the San Diego Resort, and there's a buffet, and there's tables, and there's music, and stuff like that. I sit down with my wife, and I'm starting to dig in, and I hear this voice. Is that Cameron Goble over there? And I know it's her, because I hear her every week. I'm starting to think to myself, like, okay, I can't run, because then she'll know I'm here. I'm a tiny poisonous mushroom. That's my thought, okay? I'll shrink into a little thing, and maybe she'll leave me alone. Well, she finds me. I'm being a little cynical here, but what's interesting is that she comes and she says, I really want to tell you that I appreciate what you do for me every week. I know that I'm the pain in your ass, is basically what she's telling me, right? But then she starts telling me, I want to tell you that I'm not stupid. And she begins to tell me about her qualifications for what she does. And she's not being aggressive about it. She's just, look, I'm not dumb. You're really helping me. I am a smart person. She tells me that she's, she graduated with honors from medical school. She was a Rhodes Scholar. She can translate medieval French medical texts into speakable English. Smart person, right? But it's still hard for her to learn that when you want to get connected to the Verizon network, you plug the thing in, you press the button, and you put in your login. These are the steps that she has to go through. She can translate medieval French, but she can't turn on her wireless. At some point, I'm sort of divided because I can see that she's struggling and we're having a professional conversation and we're trying to connect. But there's a little part in my mind that's like, well, if you're so smart about all that stuff, how come you're so dumb about this? And I'm a little ashamed to admit that because I don't want to feel that way toward the people that I'm here to serve. And she needs me and I can help her. But on the other hand, it's like, but you're smart. I know you're smart. Why is this so hard for you? So that's what I want to talk about today. The big question that I want to talk about is how do we talk effectively with non-technical people, even though we know they're smart. Some of the objectives that I wanted to talk about are my objectives, but I really wanted to know why you showed up here. So there are about 10 of you. I think I actually counted that right. You knew what you were showing up for when you came here, I assume. Why are you here? Why is this attractive?
I get so irritable with people.
You get irritable?
Yeah.
Did that maybe ring a little true for you, what I was just saying?
Oh, yeah. Yeah, actually, and what I tend to do is I repeat myself more slowly, but I say the same thing and it doesn't go over very well.
Sort of like if you don't speak English, right?
Yeah.
You get louder.
You get louder, you get slower, you get more deliberate. Yeah,
It makes my
right.
voice even higher.
Right, so we need to change, so how could I put what you just told me? What do we need to do here?
I get irritated when people don't get it.
Okay, so maybe overcome irritation?
Yeah.
Okay.
Or at least understand.
Maybe they should stop being irritated.
I heard Greg say like create understanding.
Well, understand why I get irritated.
Okay. Understand why I'm irritated with these people?
I know I'm irritated.
Anything else? Just what drew you here?
Well, I have to talk to non-techies all the time, and I have to explain to them technical things. That's like half my job.
So it's your job, right? Okay, that's fair.
And it's really frustrating.
It is frustrating. Oh man. Okay. There might other objectives might pop up, and we'll just go ahead and write them down. Basically, what I wanted to do was connect to what your goals are here. I can stand and talk about what I care about, but if it doesn't connect with you, then there's no reason to be here. So I want to align to that. So what drives you to come here? That sort of thing. We'll capture some specific examples we did, and we're going to make them real. All right. What I want to focus on for this is how people know things. If we're dealing with people who are smart, we're dealing with research scientists, maybe, or we're dealing with high-level administrators, we're dealing with people who have big responsibilities and they have big brains to go along with them. And yet they're having trouble understanding the technical stuff that we're trying to talk to them about and get them to understand. Why is it so hard? So I want to talk about how people really know things in general, and then we'll focus in on how it works for IT. So I've got a couple of rules for myself today. I think I've already broken a few. I'm going to try not to exaggerate. So I don't want to engage in a lot of hyperbole, like big sort of silly situations as demonstrations, that kind of thing. I don't want to take any cheap shots at users, and I don't want to be cynical, but I do want to be critical about the way that we think of how we try to connect with our users. Basically, I want to be constructive because I am dealing with real people, and as an IT guy, and as a so-called expert, a self-proclaimed expert, I know that it's easy to start thinking of people as just being dumb. But in order to overcome these kind of things, like overcoming irritation and understand why I'm irritated with people, and to do my job, I feel like we need to cultivate the ability to step back from that reaction and instead start critically thinking about why there's the disconnect so we can overcome it. So I'm going to try and do this for myself. How do we talk to non-technical people? One of the tactics that I think is common is this idea that if we can simplify things down, maybe we can turn them into things that people can understand. And some ways that we simplify our complicated IT world, we substitute easy ideas for complex ones. We use metaphors, or maybe we change our language. So we try to use everyday words instead of what we think of as jargon or techniques or something like that. Maybe we do something like try to create simple diagrams that will reduce or remove all this complexity and somehow make it as easy as 1, 2, 3, right? I don't know how well simplification really works, and I don't know that it's a really viable tactic. This is XKCD. fun cartoon comic book thing by a guy who is incredibly smart. And this is one of my favorite pieces that he did. It's the US Space Team's Upgoer 5. It is a technical diagram of the only flying space car that's ever been to another world, using only the most 1,000 words that people use the most often. All right. This is the Saturn V rocket, one of the most complicated pieces of technology for its time that took people to the moon. And it's been simplified down. I don't know how well you can read the stuff that's up there. Has anybody seen this before? Oh man. Okay, so write this down, xkcd.com. Really smart, really fun. Stuff like this. So here is a diagram taken from, let's see, it's provided, but the plans were provided by NASA through a website called upship.com. And this is a technically correct diagram, high level, of course, of the Saturn V. And it uses words like this. So this tall pylon up here is the thing to help people escape really fast if there's a problem and everything is on fire, so they decide not to go into space. Okay. This little thing right here up at the top, this little bit, is the thing to control which direction the escaping people go. What's that?
It's like hard to see the screen, so I'm gonna turn off the lights.
That's fine.
Oh, that's bad.
Oh, yeah, much better.
Okay, so this is the place where the fire comes out to help people escape. This here is the part that flies around the other world and comes back home with the people in it and falls into the water. This little container here contains the cold air for burning and breathing. This part had a very big problem once. And it goes on, and it is the entire rocket. And at the bottom is the part where lots and lots of fire comes out. It needs to be pointed at the ground, or you're having a big problem and you will not go into space today. This is a simplified language version of how a rocket works. And my question is this really easier to understand than if I say things like escape pod, attitude jet, capsule, air tank, engine? Jargon, I feel, can be difficult to overcome, but it's only because it's precise and exact about what it really talks about. Math is kind of the same way, and I don't pretend to really understand math. I'm not a mathematical person. But I do know that a simple equation can substitute for pages and pages and pages of English. And neither one of them will I ever understand unless I decide to understand math. So my question about simplification is it really easier to understand when we simplify down to the point that anybody can use the words we're using? Here's another diagram. How would you describe this diagram here? Hieroglyphics? Can you tell what's going on here? Could you guess at what this is about?
It's embroidery.
Ah, look at that. This is a chart for knitting and stitching,
Oh, okay.
right? This is what grandmas use to make shawls. One of the sort of typical go-to points of understanding technology is, if my grandma can't do it, it's too complicated. The point I'm trying to make here is that grandmas can do complicated things. Look at this. She's making a shawl, and she's got this complex map with specialized symbols that stand for something, some kind of complex procedure that she's learned how to do. It has its own language. All of this stuff right here means something to her. So it's not that she's not capable of understanding. She can turn that into that. The problem is not that it's complex. The problem is just that she hasn't learned it yet. And so I'm trying to reorient my thinking around this whole sort of, it's got to be simple for grandma fallacy, because grandmas are some of the most complicated people that I've ever encountered. And they can do specialized technical things. So my assertion is that people really are technical. It's not about the technology, it's about the technique. It's about how you do it. And people can learn complicated stuff. So my assertion is this: simplification removes understanding. It takes away the things you need in order to start building an understanding of what it is. Technique builds understanding, it gives you some complexity. There's some complexity involved, but it gives you a real framework that contains all the complicated relationships and all the complicated procedures that you need to know how to do in order to make a shawl or a rocket. So simplification takes stuff away. By substituting easy things in for the real ones, what we're doing is we're taking away opportunities for people to build real understandings. If I'm talking about where the fire comes out at the bottom that has to be pointed at the ground, that doesn't tell you what an engine does. And it doesn't give you the opportunity to start understanding how an engine works or how a rocket works. Instead, I think that what we should do is focus on building technique in people. And that means that you have to embrace the complexity of what it is you're doing, say that it's okay that it's complicated, but start with a procedure that builds at the core and allows the understanding to grow instead of substituting something simple and irrelevant for an understanding that you really need people to get. This thing over here, by the way, is another knitting pattern. Looks complicated, but somebody understands it. Here's another story. Okay, so I used to work over at the Health Sciences Center. And the Health Sciences Center has its own email system called GroupWise, right? Yay, GroupWise. Everyone loves GroupWise. No, they don't. GroupWise had a problem. It has a lot of problems, but one of the problems that it had was that it wasn't Outlook. And so when we got people coming in who had come from business worlds, corporate worlds, things like that, they would sit down and bring up GroupWise and say, this isn't Outlook. I can't use this. I don't know how this works. I don't know what it is. Now, I had never used GroupWise or Outlook when I started out, and so when I went in as a support tech, I had never seen either one of them before, and I'd never used either one of them before. I'd used other email programs, like, gosh, anybody remember Eudora?
Yeah.
Yeah, okay. So I had used Eudora, and I had used like text, CLI, email systems, and things like that. But GroupWise was new to me, and so I went in kind of without preconceptions. I don't know if that helped or not, but it did mean that I wasn't exactly resistant to it. So I started getting pretty good at it. And one of the librarians over in the Health Sciences Center said, we need to do some trainings on GroupWise because people are coming in asking the librarians a lot of questions about how to use it. Librarians don't all know how to use it. We should do some training. But we need somebody who can support it. Because it will inevitably go wrong. So the librarian was going to do the trainings in the workshop. We had a little computer lab. And then they asked me to be there just to sort of float around and, hang out and make sure that people can sign in, and if something goes wrong, if there's a need for tech support, I can be there. The way that these classes went was the librarian basically had a manual for GroupWise 5. Eventually they went into GroupWise 6. But they had a GroupWise manual, and basically she just put instructions up on the screen and said, follow me. And they were bullet points, and they were straightforward. They were short declarative sentences of click here, move that, go over there, do the thing. And these classes were terrible. I felt kind of like I was dying a little bit inside every time I went to one of them, because I saw how people were struggling with it, and I saw that the teacher was even struggling with it, because she wasn't having fun teaching. And I think that fun is actually kind of a part of learning. So anyway, she wasn't having fun with it. Eventually she moved on, but the GroupWise classes were still necessary. And so I was asked to take over the training for those. And it was my first big technical training gig, right? Back in, gosh, 97, I guess. So I took it over, and I didn't know how to design a class. So I just took what I had and what I had seen her do, and I modeled my teaching off of that. So we had the slides, and we had to click here, and we had to do that, that kind of thing. And I had done this for a couple of months, and now I was really dying inside because I was the one who was being boring. And I was the one who was having the least amount of fun. And I felt like I could do better. So one day we were doing calendaring. And calendaring is something that I thought was really super useful because I had trouble managing my time. I needed a tool to do it. And I hadn't worked with a calendaring program before. It was sort of new to me. So I was showing how to do these calendaring programs. Like, okay, everybody, let's click on the calendar link over here on the side where all your folders live. Here's your calendar. And I was looking at this calendar, this blank calendar, and everyone was signed on, and they were looking up at me. I was like, how am I possibly going to make this anything interesting? I had done this routine a couple of times, and it sucked. So I just kind of gave in. I said, okay, I'm gonna schedule a meeting for myself. What's my meeting gonna be? I'm gonna double click here. What's my meeting gonna be? I want donuts. It's the first thing that came to my head. I want to eat some donuts. So I'm gonna schedule a meeting for myself to eat donuts, all right? This is a special time set aside for me and my donut. Okay, so here's how I do donuts. And suddenly people were looking up, they're like, donuts? We're getting donuts now? No, you're not getting donuts, I'm sorry. But I am gonna schedule a time. Okay, so maybe we can all get together and get donuts. If you want donuts, then let's have a meeting. So I put something on my calendar as just a personal appointment. But if you all wanna get donuts, let's have a meeting about donuts. So here we go, we're gonna make a meeting. So what's your name, what's your name, what's your name, what's your name? Here's how I look you up in the address book. Okay, now you see how I got up to the address book? Now I'm gonna put in a meeting for us all. Donut Appreciation Society. 2, you, and you. Okay, where are we gonna meet? Well, here's the location bar, so I'm gonna say that we've got a special room for donuts. It's called the Secret Underground Donut Appreciation Bunker. So we're gonna put that in, and I'm gonna type in a little message. Hey, what kind of donuts do you want? Remember to bring sprinkles, who's on, and I was building a meeting around this sort of ridiculous idea that we're all gonna like drop what we're doing in the middle of the day, secretly sneak off to our donut bunker and eat donuts. And then I send the meeting out, and people see meetings appear. And they're like, what do I do? And I say, what do you think you do? And they say, well, I want to eat donuts. And I say, how do you know that how can I know that you're gonna show up to eat donuts? And they say, well, I see this accept button. What do you think that does? I think it means it goes on my calendar. Click it. Hey, it did. Suddenly, we're shooting messages back and forth about donuts, but we're doing it using the system. At no point did I delve into the intricate complexity of like reply to and what's gonna reply all gonna do and all that kind of thing. What I was really trying to do is get them to push the buttons and see what happened. And it was a safe environment for them to do that because we had a bunch of like little training logins and stuff like that. So that's how I got people to care about the calendar. After we did the donuts and stuff like that, they had a little context to see how the messages went back and forth. They knew how accepting and declining worked. Oh, I clicked the decline button instead of the accept button. What did that do? Now it's not on my calendar anymore. How do I get it back? Okay, now we can go into send items and do a resend. Now I can get the properties of my meeting and see who accepted and who declined. And now I know. So the moral of the story here, I guess, is people like food. But it's also the goals that people have do not include using the technology itself. The goals that they have are the goals that they have. They don't want to schedule a meeting about eating donuts. They want to eat donuts. And what they use to schedule the meeting is kind of incidental. They need to know how to use it, but it's always got to be focused on something that's real. So what I discovered was that was one way that I could get them to learn. Instead of being sort of bored, dull, disengaged people, suddenly they were clicking things, they were playing with things, they were learning things. And they were telling me what they were learning because they were getting results that they liked, or they were getting confused, but they were using terminology that was real and complex. They were using it in the service of their goal. So I've spent the last maybe 14 or 15 years professionally dedicating myself to understanding this question. How does this mush between my ears turn into something smart? How do we learn things? And what I want to do now is share some of what I've learned with you so that you can pick it up and take it back to your non-tech people who need to learn the techniques that you know how to use in order so that they can achieve their goals. So it's going to get a little academic here, but that's okay because we work for UNM and we're an academic institution, so I think that's all right. A man named David Goble, back in the 1980s, he was an educational researcher, so he was researching how education worked. And he came up with a simple definition of learning that we're going to build off of. Learning is what happens when new inputs are perceived by the brain and processed into meaningful connections. So You hear something, you see something, or you think of something new, and then your brain processes that signal into something that has meaning for you. Okay, this is what learning is. How does learning happen? We perceive a new input, and that comes from two places. It can either be from concrete reality, like I just said, we hear something, we see something, we taste something, we feel something. Or it can come from a sort of abstract place, like we come up with a new idea. We're thinking about things, and suddenly two things come together, and we're like, oh, new stimulus, I'm going to think about that for a while. After we perceive it, we process it. So by processing it, we can either test it actively, so we can take it and try and do something with it, or we can observe it and reflect on it and be more passive about it and try to connect it internally to something else. So these are Kolb's two segments, right? Perceiving and processing. And they happen on these sort of continuum, right? So maybe you're testing something really heavily, but then you're writing a reflection paper about it. Or maybe you're doing some research and reading somebody else's paper about it, but then you decide to test it in the real world. So depending on what it is you're doing, and whether it's just an idea or whether it exists in the real world, you can create these sort of mixes of what you're doing as you learn. So I'm going to put those on two axes, right? And depending on where you go, depending on what you're doing and what you're doing it to, you can float in all of these quadrants. What's really interesting about this is that Kolb was an educational psychologist, right? He was dealing with abstract ideas. He was doing research on how people learn. He was trying to test people's competencies. He would have them do things and perceive things in different ways, and then see what skills they had learned coming out of that, and that's how he was testing it. In 2005, I think, a researcher named Zull, Z-U-L-L, was thinking about Kolb's problem. The problem with Kolb was that Kolb hadn't figured out how the brain actually works. He had just figured out how learning worked, and that was kind of too abstract for him. So what Kolb did, as a neurologist, he started looking for the biological structures that would reflect the change that would have to happen in order to learn. And what he discovered was something really interesting. The human brain is, for his purposes, divided up into four basic segments. There's the part that perceives things, there's the part that remembers things, there's the part that sort of abstractly processes things, and then there's the part that reacts to it. Okay? So here's what happens. If my eyes are over here, this is the back of my head. So my spine is right over here. The brain is connected to the gigantic network of nerves that make up my senses in my body, right? So I can feel things, I can taste things, I can smell things, I can see things. Those all come into my brain through the spinal cord into this part called the sensory and post-sensory part. Notice how I'm not saying it's the part that sees things. The sensory and the post-sensory part. And what it does is it takes in that signal and says, aha, I've got a signal. I'm going to process it into something that means something to me. The post-sensory part shoves this over to the next part of the brain, which is the temporal integrative cortex. All right? The temporal integrative cortex is where your knowledge lives. It's how you remember things. It's how you know what things are. When I look at you, sir, I know you are wearing a hat. I know you are a person. I know we are in a room. I'm receiving signals that get pushed from this part into the temporal and integrated cortex. This is where the memory lives. It starts assigning meanings to what I see. Once I have the meanings, the temporal integrated cortex pushes it to my frontal cortex. My frontal integrated cortex is where I can start understanding concepts. I know how things relate to things. That is a hat. You are you. You are wearing a hat. The hat keeps you warm. The hat covers your bad hair. The hat, right? I have meanings associated with the hat. I know what the hat is. Now I know what the hat does because it's turned into something that I can start creating relationships around and forming hypotheses around. Maybe you don't have bad hair. Once I understand the concepts, my brain pushes that signal over to my premotor and motor cortex. This is where I start making plans. I want a hat too. So, as it turns out, I have a hat way over there with my jacket over by that camera, so maybe I'll walk over there and get my hat and put my hat on. What's cool is that the process that Kolb thinks learning goes through, right? This testing, observing, abstract, and concrete, matches very closely to the actual processes that happen in your brain when you observe something. Remember what it is, think about it, and then plan to do something about it. So there's this cycle that happens according to Kolb, who's an educational psychologist, and the same cycle is reflected in the biology of the brain. This is how learning happens. What's neat about it is that, all right, so I work for HR. Has anybody done like a DISC profile or any of that stuff like that? The thing where we tell you like you're an introverted, perceptive, Myers-Briggs test and that kind of thing. Maybe you look at this and you're like, oh great, he's going to draw another little graph and tell my horoscope using that. What's cool is that this is actually backed up by a biological process that we can measure and see in real time with like MRI scans and stuff like that. Technology that I don't understand how to use, but I know what it tells me. So everybody has a brain that pretty much works the same way. You receive an input, you figure out what it is, you figure out what you can do with it, and then you go and do it. And it just cycles around. That's how you learn. Remember that everybody has a learning brain. So if everybody has a brain that can learn like this, why is it so hard for some of our non-technical people to catch on to what it is that we're trying to teach them and support them in as we're talking tech to them? Why is it so hard? Why is it so hard for people to get it? All our brains pretty much work the same way. Why is it so hard? Anybody have any paper? Can I get a volunteer from the audience? Nancy, you want to come volunteer? Come on up. This is going to be fun. Now, we've never met before. And you notice I have nothing up my sleeve, honestly. All right. Nancy, will you write your name and your address up on the board for me, please?
My home address?
You can make up an address, just something with numbers and a name for a street address. Everyone lives there. Excellent. All right. What do you think? Can you read that? Nice, clear? You use your right hand to do that? Put the pen in your left hand.
Okay.
Try writing your name and the same address in your left hand. You're not ambidextrous, are you?
No. Obviously. Oops.
Went the wrong way there. Okay.
Yeah.
It's taking you a while to get this one done too. Right?
Oh, yeah.
Yeah.
It's painful.
It's painful? How's it painful? What are you feeling while you're writing it there?
That it doesn't make sense.
It doesn't make, like your hand is going backwards
Yes,
and stuff like
yes,
that?
yes.
Thank you very much, Nancy. I appreciate you doing that. If you want to experience why it's so hard for non-technical people to understand technical topics, do this. Go back to your office or take out a piece of paper if you got one, or even if you got your tablet, like draw it out with your finger or something like that. Write your name the way you're used to, and then switch hands. This is what it looks like. I do this too. You try it with your other hand and it looks like crap. Why is this? The reason why this is that while everybody has the same parts of their brain and the same parts do generally the same things, some people have more neurological capacity in different parts of their brains than others. Nancy, when I asked you to write your name, you took out the pen and you used your right hand because that's where your capacity was. It's how you know it works, and you just put it right up there. When I asked you to use your other hand, a whole other part of your brain had to do the work because there's like hemispherical modes and stuff like that. A different part of your brain, a different set of neurons had to do the same kind of work that you had normally done with another part that was better at it. This is what learning is. Your neurons get better at doing things the more you do it. When we ask non-technical people to do technical things, it's not that they're non-technical, it's that they haven't done those things before. If you wrote with your left hand all the time, you would be great at it. So it might be almost like tautological, like nonsensically obvious to say that people who do things more are better at it than people who don't. But the thing is that we're trying to teach non-technical people techniques, and we teach them in the way that we are used to, because that's what we do. We have a way that we know how we learn, and it seems obvious and intuitive to us. But if you're talking to a brain who has neurological capacity in some other way of learning, they're not going to learn the same way as you do. And it's going to be like them trying to write with their wrong hand. This is where learning styles come from. So here are what learning styles look like. This is cold again. We've got the abstract, concrete way of thinking about the world, and we've got the testing, observing way of processing our information. Different learning styles look different ways. If you've got a learning style where you observe the concrete world, what you like to do a lot is to discuss things at length. You like to talk. You like to put words in the air. You like to hear other people talk back at you. You like to express your values, what you think about the world. You like to measure the effects that your actions have. And you like to establish goals. I'm doing this for a reason, is what you like to say. So you ask questions, why am I doing this? If you like to observe the concrete world, if your brain is most used to thinking about and learning in that way, this is what you're going to go to naturally. If you're an observing abstract person, so you look at the world and you are thinking about it in terms of ideas, then you like to read things at length. You like bullet points. You like definitions of things. You like charts and graphs. You like little symbols that mean something to you. The question you ask is, what? What is this? If you are an abstract tester, that is, then you like to follow instructions. You like to interpret meanings and rephrase things, right? You like to put things together and you like to take them apart. You like to see how they work. So you ask the question, how? And if you're a testing concrete person, that is, you like to encounter the world as it is and do stuff to it to see what happens, then you like to make plans, you like to create new things, you like to speculate on what might happen if, and you like to personalize your world. You like to say, well, that's great, but I would really like it in blue. So you ask, what if? Depending on which part of your brain is most in control when you are in your zone, in your learning zone, you're going to express your learning in one of these ways. It's not that you don't have all of them, it's that there's a particular way that you like. IT people generally favor these kinds of ways of teaching, especially this one. Reading at length, doing bullet points, getting definitions, charts and graphs. This is things like the definitions and the plans that are already created. Following instructions and interpreting meanings, this is things like following manuals. I'll go look it up in the manual, or I'll go onto the internet and find it. But that's not the only two ways of thinking and learning. And I'm not saying that there aren't people in IT who don't like to do this and don't like to do that. In fact, we all have a mix of these qualities and these ways of learning. So when you see people behaving in a particular way, when you see them learning in a particular way, when you see them catching on in a particular way, you're actually getting insight into how their brains are working. And when I was putting this together, I was thinking about like what teaching tools do we have that express in these different ways? Like reading at length and bullet point definitions and following instructions especially feels a lot like fast info to me. And so when we point people at fast info, we're expecting them to learn in these two ways. But if we're dealing with somebody who learns in these ways, like administrators, or if we're dealing with people who learn in these ways, like maybe scientists, they're not gonna, it's gonna be like them trying to write with the wrong hand. It takes more effort for them. They're gonna get it wrong. It's gonna be slow and frustrating for them. It's not that they can't learn, it's that they don't learn this way. I know we only have a couple of minutes here, but we are pretty close to the end. So learning structures reveal brain cycle structures. And what we want to do to teach our techniques to these people who don't know our techniques yet is to present the learning in a way that it fits into this brain cycle so that it touches all those parts of the brain. So there's a supportive learning cycle that we can use. we can use the questions that each part of the brain is keyed to ask. And we can start in a simple procedure. So our learning cycle goes like this. When somebody comes to us and they say, I need support, I need help using this email client, I need help using the web, I need help using Cascade, I need help in biology department, we just deployed a new thing and I don't know what it does. And I need to get something done. One of the first things we can do is ask why, and listen to what the people are telling us about their goals. Because they're not trying to use the technology just for its own sake, they're trying to do something with it. They don't want to schedule a meeting, they want to eat a donut. So we ask them the goal of their support and we let them tell us in their own words what's going on. That activates the first part of the cycle. Then we give them the what. Here are the straight facts about what you need to know. This is called this is called that. The web server content management system is called Cascade. The biology server, file server that these things live on is called, I don't know, whatever. Then we provide the how, provide them instructions and practice. It's important to give them practice as well. So this is where you start coming in with your fast infos and stuff like that. Up here, you're having a discussion about what the point is. Here, you're starting to define the context that they're going to learn in, the things they need to know. Here's where you actually give them what they're going to do. Finally, you help them make their own plans about what they're going to do with themselves by asking what-if kinds of questions. Ask them what they're going to do next. So, hey, we've just gone, you wanted to eat a donut, I showed you what an appointment is, I showed you the buttons that you need to use. We practiced making a donut appointment. What are you going to do next with your new appointment making skills? Well, I'm going to schedule an office in the dean's department so that we can have like special dean donuts or something like that. This gives them the opportunity to connect what they've learned back to what you've given them. So the big question that we had today was, how do we talk effectively with non-technical people? Here are some tactics that I think you can use that will be effective for you. And these are the takeaways. If you care nothing else about my fancy brain diagrams and stuff like that, this is how I learned how to support my people, my nurses and my administrators and my people who don't care how the computer works, my people who would rather kick it out the window. This is how I got them to use the computer well. Recognize that they are already technical somehow. Admit that they can learn it. They know technical stuff. If I was asked to do a nurse's job, I would have a long line of corpses behind me. They've learned something complicated. They can learn this. When you're trying to teach them, favor their goals and their experiences, not the tools. Don't worry about selling the tool. The tool is what they're going to use, and they're going to have to learn the tool. But they're going to learn it for their own reasons, and it's going to connect to their own experiences. Ask open-ended questions. Ask why, ask how, ask what next, ask what if, and let them fill that in. One of the ways that you can prove to yourself that you've done a good job giving people techniques and helping them learn is that if you give them an open-ended question, they will tell you something with detail, not just yes or no, right? Avoid those yes or no questions while you're trying to teach. Ask them why, ask them how, ask them what next. And when they can tell you, and it's cogent and it makes sense, that's how you know they've learned something. Or that's how you can diagnose what they need to learn next. Finally, mix it up to activate their whole brains. Don't just point them at fast info and say, here are the instructions, go there. Ask them questions. Give them opportunities to practice. Approach them in different ways. Let them speculate. Let them define things for themselves. Ask them what the little button is that they're confused about. What does it look like? What do you think it does? Mix it up for them instead of just shoving the information at them. You'll get their whole brains involved, and that's when they'll start learning. Fancy transition. So the big question was not really how can we talk technically to non-technical people. There's no such thing as a non-technical person. We all know technical stuff. It's really how we can help people to become technical in new ways, new technology, new techniques, new technicality. If you want to see what this is like, try getting something new for yourself. One of the things that we forget as teachers is that we can also take classes and learn new things, and that's the best laboratory for understanding how learning works. So find someone who knows how to do something you don't. Ask them to teach it to you. Give them the opportunity to experiment with it. They're going to mess it up. That's okay. They're experimenting with their own teaching. But now that you know how brains work and a little bit more about how teaching works, Monitor how you're learning so that you can see what happens as you teach, or as they teach. I hope this meets some of our objectives, overcoming irritation. I don't know if I can overcome irritation for you, but maybe understanding why it's irritating, coming up against that wall. Now we know there are different ways to penetrate that wall and get into people's brains and help them learn things. So hopefully this meets our objectives. So those are some of the drives that we had, and we talked about those. Here's the reason I came, and I am almost done. In the 20th century, computer skills were the skills that could be sort of foreseen as what everybody had to know in order to have a good job, to achieve their goals, to do the things that would make them successful. In the 20th century, as computers were starting to go up, the futurists were going, computers are going to be everywhere, and they are. I think that teaching and learning skills have that same capacity. I think it's what everyone is going to have to really understand and be comfortable with in order to be successful as the 21st century rolls along into the future. We've kind of got the computer skill thing down. They're pervasive, they're everywhere. Everyone's got a computer in their pocket. I've got one right here. And we know how they work, and we know how to interface them. Computer skills are not the problem. The problem now, I think, is understanding how to teach what you know and being able to learn something you don't know. Flexibility. That's why I'm here. My name is Cameron Goble. I'm with HREOD. I'm happy to come talk with you about technical training stuff. I also have a blog, so camerongoble.blogspot.com. I talk about IT training stuff all the time. And that is that. Thank you. If anyone has any questions, comments, or would like to just sort of hang out, I'm eager to.
Well, I do have a question. What do you do with a person who, and I'm sure we've always, everyone's experienced this, who has, I just can't learn this stuff. I mean, they can't learn it because they've said in their mind that they can't learn it. How do you overcome their resistance to wanting to learn this stuff?
If they've already convinced themselves that they can't learn, the first thing that you do is convince yourself that they can. All right, you can't let their doubt get in the way of what you need to do with them in order to produce the results you need. So you've got to believe that people can learn. And this is part of why I had those rules about like not being a cynic, not taking cheap shots, that kind of thing. It's hard to do. And I know in IT we have our own special brand of commiseration. But we have to believe that people can learn. And at that point, what you do is you find the smallest thing that you can, that they can learn. You ask them to explain what they think this thing does that's giving them trouble. And you get them to express it in their own terms. What that does neurologically is it's what we call activating prior knowledge. It wakes up the neurons that actually do know about things. They probably have already learned a lot. If anything, they've learned that using this particular program causes me pain. Right? But then you can start asking questions. Well, what goes wrong? What hurts for you? What happens that makes you not like it? And then they will describe the situation. And then you can start teasing that apart and saying, okay, well, if this is the thing that's giving you trouble, let's start working on that. And then you start going through that cycle again. You say, here's the goal of why you want to use this thing. You're not trying to use it just because you're told to use it. You're trying to use it because you have a job to do and you have a mission. So that's what you do, is you get them to tell you what they know, and then you zero in on some little thing that you know you can fix today. It doesn't have to be a complete fix. That's the other thing. And I'm going to engage in this fallacy. We don't have to provide complete learning. We just have to provide enough. And actually, if you try to provide too much, your brain is going to get full, and it's not going to care. I get the feeling that this is way too long of a presentation, to tell you the truth. So we don't have to be complete about it. Just find the one thing that's going to convince them that they can take one little step, because that's what brains are wired to do. They love those one little steps, because suddenly it cascades. It's the network effect, and suddenly things open up. That's how you build that momentum. Yes?
Well, I was listening to you, I was thinking of like an ideal world where I would just be focused on what I have to get done. And the people I provide support for the most part, are really slammed with their own responsibilities, like they feel really under the gun. And I do better when I actually do take a minute and I express interest in what their needs are and what their particular workload is. And then they feel like I respect what they're trying to do. And then once I do that, the communication improves. But that's an ideal world if I don't go in where I have 5 minutes to like do the same and you're taking me away from my time to get my stuff done. You know, it's a different approach.
It is, and it can seem like it can be really time consuming to think about it this way. Instead of just presenting the information, why do I have to have a conversation about it? My time is valuable. How do I do this and still, have time for anything else, especially if I'm supporting a large department maybe with a lot of people or very varied levels of technical proficiency, that kind of thing. All I can say is that you can have fast conversations where people do learn. And again, it comes down to this idea of you might not be able to completely support them, but you can help them build a little something every time. So, if you're slammed and people are like, fix this thing, yeah, you have to fix the thing. I mean, that's just part of what you have to do. But if you can identify the one little bit that they can learn for themselves and take away with, they don't have to know how to fix the whole thing, but they can get a little bit, and that's going to open something up for them. That, especially your problem users, people who keep coming back to you, if you can give them that one little bit that you know that they got it, suddenly they're going to have a lot of bits. After that repeat exposure, they're going to keep coming back to you because they're your problem child or whatever. If you give them that one little bit, it's going to grow, and they're going to stop being your problem child. That's what happened with my nurse that I told you the story about, who came and found me at Christmas. I figured out how to give her the one thing she knew how to do. And when she would call me, I would say, well, what did you do? And she would tell me the one thing that I had told her. And that's how I knew she was starting to get it. So it's a snowball effect, it's an avalanche.
Yeah, I also think that when that happens, it's good to point that out to them, like, you're learning it!
Yeah, see, you got it!
Yay!
Yay! And celebrate that. They need that victory.
How to go to
They really need that victory. That's another thing too, is when you're talking about how do these people who have convinced themselves that they can't learn, you show them they did. And you don't even have to prove it to them, they just know it happened. They're like, oh, I guess, hey, wow, I did. I love that part of teaching. When people know they're getting smarter themselves, they don't need me. I want to live in a world where I, as a teacher, am not really that needed. I want to live in a world of creative, fulfilled geniuses. As it turns out, thankfully, I get to keep my job for a while, but that's what I'm aiming for. Please get in contact with me again. Look me up in the directory, camerong@unm.edu. I'd love to sit down with you a coffee and talk about how we can integrate some of these things. If you have particular needs, that sort of thing, but I've taken up more than enough of your precious time. Thank you all for being here. I appreciate your work.
Do you have any last items before we adjourn? All right, we'll see you all next month, hopefully.